Hello, good morning. Start the session. So yesterday we have discussed about exception handling concept. Okay, so I did not give time for writing the program, right? Okay, so it's a runtime error. So basically, we'll have three blocks: try, catch, and finally, in the try block, we'll write the main logic, and catch will be exception, and finally, so it is like when we are getting output properly from try block or catch block, it will hit the finally block, and it will come out of the that. I mean that from that block. Okay, fine. So we have seen, I have explained a few examples for that. See, for example, so I have given like this division related. See, division is possible when we are giving the proper values only, like 6/2 something. But when we are giving 0/6 or value by some ABCD, some kind of text or something. In that case, what will happen? So division is not possible, and it won't give any proper output. That's the reason. So we can expect some exceptions. So based upon that, we have implemented few things here. So see here, the first I am entering two values here, and after that I'm trying to read those values from command prompt. So we are doing the division. That's it. If everything is fine, then we'll get the output from here. So then it will go to finally, and it will print the output, and it will come out of this block. Okay. But for example, divide by zero exception. So when we are trying to divide the value with some zero, then what will happen? So it won't give the proper output, right? That's why we can expect this exception. Format exception. For example, when we are performing division operation, we definitely need what? Only integer values. But if we by mistakenly if we enter string value or something else, in that case also we'll get the format exception. So for example, these two only the expected exceptions in this case. But if you think something else may come in future, or for safer side, what we are doing here is, so we are just keeping. So Siva, I explained this one already yesterday. That's why I'm going fast. So if I explained already something, then I will go a little fast for that, because that's the revision. Okay. So if we think like if something some exception will come, so like see, we identified two types of exceptions here. If you think the third exception will also come, then in that case, for safer side, so we just kept default exception some object name equal to and here what we are doing, so whatever the exception here, inside that we will have some message. Okay, we are just printing that message, but this won't come in this particular scenario, but safer side. Okay, that's why we kept like this. So then what will happen? The exception will be logged, and any user can go through that log file or something, then they can easily check the exception. But anyway, we are not logging anything here, but simply we can go with the console application, and we can see the output, and we can see the error. Okay, I'm just running my program. So initially we'll go with valid thing 6 divided by 2. We got the output, and see this one from where? Try block, and this one from finally block. In real time, it's not mandatory to keep finally something. So if you want, we can keep. Otherwise, we don't need. We can go with only try catch. Okay, we can throw different type of exceptions also. So based upon our output and all. So, but anyway, this is basic level. No, I will divide with 0. So divide by 0 exception. So we cannot divide we cannot perform division operation like with 0. That's what. So see here, what is the common again? Finally block. So if it is executing in try block or catch block, the finally is what? The common. Okay. And similarly what? 0 by 6. So the value is what? 6 only. Okay. 0 only. And what else is pending? 6 divided by A, B, C. Okay. So this is what? See, format mismatch. That's why it is going to the second catch block. Okay, note down the program. So the theory everyone note down, right? Yesterday, anyone did not wrote. So if people want me to show the theory again, yes, no. Okay. Shall we move to next topic? Okay. Okay. Generics. Generics means general data types. So here the advantage of generics is we can specify the data type at runtime. Okay. So see, for example, if you don't know data type exactly what you want to give the data type as input or output or something, if there is no clarity, then we'll go for this generics. Actually, generics notation will be like like this. Okay. So variable name. Okay. So what will happen here, whatever the type you specify here, again, you need to specify the same type or data type. TP. What is TP? Means data type only. So basically generics we can apply for methods, variables, class, properties. So we can apply anywhere within the constructor, everywhere wherever we want, we can apply these generics. Okay. So this the less than and greater than is called as placeholders. Okay. What is that? Placeholders. Okay. So what we will do, we'll specify the data type at runtime. Okay. So what will happen? We'll specify the data type at runtime. The main advantage of generics is we don't need to do any typecasting here. For example, so what I was telling, so we are passing the value at runtime, right? For example, I can pass integer, I can pass string, I can pass char, double, float, anything. But we don't need to do any typecasting there. That's what the advantage of generics. So if we exactly don't know what data type we are going to pass, or if we don't know what type of data we need to pass, then in that case we'll go for generics concept. Okay. So basically generics means it's general data types. They are they are introduced in .NET 2.0 version. Okay. Okay. So by using generics, we can confirm data type at what time? Runtime. Runtime we can confirm. Generics avoid typecasting like boxing and unboxing. Why? Because runtime, when we are giving the value, we can directly use the value. Okay. These are implemented using generic notation. What is the generic notation? This one. So within the placeholder, we'll specify the data type. Okay. So we can apply generics for methods, class, variables, properties, constructor. Everywhere we can apply that one. Okay, this one. Okay. So we'll just see one example. This is very easy topic. Now tell me, what is generic notation here? So see, this one. TP. This is what our data type. So where we'll specify runtime here. Okay. So whatever the value you want to display, you can display. See, whatever the value you want to pass here, you can pass here. Where we can pass at runtime. Okay. So see, this is method name and type safe function, and here, so we are just passing the value. So similarly, okay. Similarly, here we are passing the data type and value. Okay. So just note down, okay, just keep an heading of generics and this syntax. We'll see one more example, few more examples. Okay, if I run the program, we are displaying the output. Okay, generics and take the syntax and that example. It is type safe variable. Simply, we will pass the data type, which data type it is. So that's why. So it's type safe only. So TP is nothing but type safe. For generics notation, we will use like this. So whatever you are seeing here only we will pass the data type. Okay, so I'm going to the program. Okay, so Asmi, we'll move there. You want to write complete theory or can I move there? Note down the example. Okay, we'll go for one more program. So if you people see here, we kept generics notation for whom? Class. Okay, TP is what? Type safe function. So people see here. So here we kept the method name simple. Just see that. So where we are passing the data type, here we are passing the data type. Okay, here we are passing the data type. So what is happening here? So whatever the data type we are passing, we are taking the same data type here. Okay, so here I'm just creating an object for that one, and I'm just passing the value here. So now what will happen? Previously here we specified the generic notation. Now what happened? We specified for what? Class only. We did not specify for method. Okay, that is the difference between that program and this program. And finally, what is happening? Runtime. We are specifying the data type here. We are directly passing the values without any typecasting. Okay, so let's see the output. Okay, that's it. Okay, done. Okay, no done. So done, everyone. Yeah. So anyone is writing? Okay. So we'll move to next topic. Delegates. So here we have written some steps for delegates. Just check that one. That program only we wrote. Parentheses. Okay. Delegate. So in C language, we have a concept called pointer. So what pointer used to do? So a pointer will help us in storing address of some particular variable or output or something, right? So similarly, if you want to do the same, we have a concept called delegate. So for a change here, what we will do, we will store complete object output, not a single variable or something. So we'll store complete object by using this delegate, and we don't call that object or something else. We'll call this delegate and we'll get that output. Okay. So that's what delegate. So we'll explain that one in detail. Each and every point we'll go for it. So basically, delegates are of two types. One is single cast delegate and multi-cast delegate. Single cast means what? So simple. One object values will store. Multi-cast means we can have more than one object. Okay, that's what. So we have some steps to work with delegate. So first I will explain here. After that, in our notepad, I have written the points step by step. So we'll follow that. After that, in program also, step by step I have explained there. So we'll follow that, then definitely everyone will understand. Step one. So how to work with delegates means the first step is we need to complete class level code. So why we need to complete class level code? Because if you want to work with delegate, what we will store the method output in object. So the complete object will store in some address location or something. Then what will happen when we will create object, once we are done with our coding only, we will create object, right? Then first we need to complete class level code. What is class level code? Like variables related, methods related, everything you will write. Okay. Step one is completed. Okay. Now the step two is create delegate. Okay. What is that? Create delegate. Step two. Now the important point of the concept is syntax. Access modifier delegate. So just copy this one. It's better to copy when we will write. So this one. The syntax for creating delegate is access modifier, delegate, return type, delegate name. So now tell me, what is the syntax for declaring delegate? Yeah, please repeat with me. Access modifier, delegate, return type, delegate name. Okay. The syntax for creating delegate is so the syntax for creating delegate is access modifier. What is access modifier? Public, private, protected, whatever we want to keep, we can keep. So we'll give some example for it. So example, public. So delegate, return type, some delegate name. That's it. So keep a semicolon here. What is the first step? Complete the class level code. What is the second step? Create the delegate. What is the syntax for creating a delegate? Access modifier, delegate, return type, delegate name. So can you people tell me what is the syntax for creating a delegate? Yeah, tell me what is the syntax for creating delegate? Yes, tell me what is the syntax for creating a delegate? Access modifier, delegate, return type, delegate name. So yes, only one person, two people. Okay, fine. So very good. Three people. Okay. So the syntax for creating a delegate is access modifier, delegate, return type, delegate name. Basically, the main purpose of delegate is what? For storing particular object value. So it's like pointer in our C language. Okay. So this is what now the third step. So now we have implemented class level code. Now we have delegate also. Now what we need to, so we need to store our object complete output in our delegate. So now what we need to do here? So create object to class. Create object to class. So this one we people know. Step 4. Now create object to delegate. So this one. Okay. Create object to this one. Okay. So now here only pass the object values. Okay. And the final step. Now we need to call delegate object. That's it. So we don't need to call this class object. So we are storing in this address location. So we are creating the object for delegate and we are calling that one. Okay. So we are not calling anything related to class. We are calling this delegate, this address location, and we are getting So this class level output. Okay. The syntax for creating a delegate is access modifier, delegate, return type, delegate name. Okay. So we'll go to our one more notepad. So here I explained with point to point. So we'll see here also once. Okay. The first one. So step one. What is the step one? Complete class level code like variables, methods, and etc. So example method, public void, something. Okay. The second step. What is the second step? Create delegate. So what is the syntax for creating delegate? Access modifier, delegate, return type, delegate name. Okay. Now create an object to class. Which class? Here, the step one class. Okay. Create an object to delegate from where? Here, step two. Okay. So and pass the method values, whatever the method output you want, just object name dot method name and pass that one. And the call the delegate. So what is the syntax for calling a delegate? Delegate object name. Okay. We'll see a simple example for that, and we'll come back to theory again. Okay. So any questions in delegate? So we will understand the importance of delegate in our MVC sessions. Why? Because so other people will come to us and they will ask the doubts and they will ask us to repeat this delegate concept. Just wait for few days, then you will understand. So simple. Now first, what is the step one? Why did not wrote here? Okay. Okay. Now here we will update the code. What is the step one? Tell me, what is the step one? Complete class level code. That's what we have done. So we have written one class and method for that. So here our class got completed. Now step two. Step two. What is this step two? Create delegate. What is the syntax for creating a delegate? Access modifier, delegate, return type, delegate name. Okay. See, what is access modifier here? Public, delegate. This is return type, delegate name. That's it. So step two is completed. Now people tell me, what is the step three? Create object to whom? Create object to delegate. Create object to whom? Class. Okay. Now, what is this? This one is what? Step three, right? Step three. Okay. Now step four. What is step four? Tell me. What is step four? Create object. Create object to whom? Delegate. Delegate. And what else? Oh, and what else we need to do here? And pass the method output here. That's the. Oh, see, this cursor is not listening my words like you guys only. And pass the method output. Okay. See, that's what. What is this D name? This delegate name. Some object name equal to new delegate name. So T1 dot P1. What is this P1? We'll see that. What is this P1? It's a simple method. Okay. So now whom I am calling? Delegate one. See, I did not call my method. I called my delegate only. So I stored the, so this is my address location. I stored the values here and I'm calling this one. Okay. Now let's see the output. Okay, that's it. Got it right? So now this step 5 also I will write. Okay. Step 5. Now tell me what I'm doing in step 5. Call the delegate object. Okay, that's it. So we'll copy this one, maybe for future reference. Now one question for you guys. Now how many methods output we are storing here? One. So that's why it is single cast delegate. Multicast delegate is different. Okay. Anyway, once we are done this program, we'll go for it. No problem. You people don't need to worry. Okay. Any questions? Can I explain again? Yes. No. People tell me. If you want me to explain again, I will explain again. Okay. So this. Okay. So see. Anyway. See, it's like pointer concept only. So whenever you don't want to expose your real object, in that case, we'll go for delegates. Okay. So see, again, I'm explaining one more time. See, it's already 6:53. So when you write this theory and also, then what will happen? It will be 7. So again, tomorrow when I'm doing revision, I will go little fast. I cannot take, see, now I almost took half an hour for explaining the process of delegate. So again, when I'm doing revision also, if I take half an hour or something, then what will happen? So after 6 months also, C# won't complete. That's why the revision I always go little fast. Explanation I will take time, maybe half an hour or 20 minutes or something. But revision I will take 5 to 10 minutes, and I need to do complete revision on I mean yesterday classes and all. Okay, so try to understand. Fine. So what is the step 1? Complete the class level code. What is the step 2? Create delegate. What is the syntax for creating a delegate? Access modifier, delegate, return type, delegate name. Okay. So create object to class. Create an object to delegate and store this class output here. Okay. And call the delegate. And finally, the syntax for that is what? Delegate object name. Okay. This is what the steps to work with the delegate. So just keep an heading of delegate and note down this one. So the steps are there in the book, but not this much clear. Okay. These are the step by step we have explained here. That's why I try to prefer this one. So are you guys done? Yes, no? Okay, fine. Fine then. Thanks all for joining. So tomorrow we'll see the example.